we had seen that when you write this electron configuration, that electron configuration is a shorthand way of writing the wave functions for the electrons in a multi-electron atom within this one electron wave approximation. But we also noted that at most we assigned a hydrogen-like wave function to 2 electrons. And we noted that that was because of something you already knew about called spin. And spin last time we saw was a quantum mechanical phenomena. Spin is the intrinsic angular momentum built into the particle. And we saw that spin is designated by a 4th quantum number. That 4th quantum number here is m sub s, and it had 2 allowed values, and those allowed values were 1/2 and -1/2. And we said that those 2 allowed values, or those 2 states, represented a spin up and a spin down. 2 different polarities, in a sense, of this quantum mechanical phenomenon called spin. All right, now, how was spin actually experimentally observed? Well, really thanks to these 2 gentlemen. Here's Uhlenbeck and Hutschmidt. These were very young scientists, I think postdocs at the time. And what they were doing was looking at the emission spectra from sodium atoms. And this is 1925, and so they knew enough already to know at what frequency they should expect to see some emission. And so they looked at the emission, dispersed it, looked at that frequency, and instead of seeing emission at that particular frequency where they expected, they saw, so if this is the expected, what they really saw was some emission at a little bit lower frequency and some emission at a little bit higher frequency. Not much, but a little bit lower and a little bit higher. Okay? And in spectroscopy, this kind of emission is actually called a doublet. Well, they were quite